20 divided by 2. What will they give us? 10. So you can see automatically the note is showing us the answer, so we'll be able to know. Let me check through what is going on here. So divisibility rule for 2: a natural number is divisible by 2 if its unit digit is divisible by 2. By the way, what do we mean by unit digit? Let's not forget our tens and unit, our place value. Yeah. So if we have, you have something, if you have a number like 2, there's only one place value here, and that's like unit or ones, right? So if we have maybe we have 25. So here we have 2 place values. We have the tens and then we have the unit, right? You already understood that. And the tens is the 2, while the unit is the 5 is going to be the unit. Okay, so sorry, let's say you have 2, 4, 5, 6. So the what's it called? The unit digit will be 6. You can see 6 is the unit digit. What about 5? 10. 10's digit. What about 4? 100 digit. What about 2? 1,000 digit. Yeah. So what we are saying is that if the very last digit of that number we are trying to check if it's divisible by 2, if the final digit, the last digit by your right itself is divisible by 2, then the number itself is divisible by 2. Is it not simple? Is it not simple? Like this number now, 2456, that's 2,456. 6 being the last digit here is divisible by 2, so it means we don't even need to solve anything. This number is divisible by 2. Let's see if we have examples from this from what we have here. Look at, okay, we have 4,546, 53,952, because it ended in 2, so it's divisible by 2. Look at this, it's even in hundreds of thousands. 648,394. It ended in 4, so it's divisible by 2. That's all. It's so straightforward. I mean, math is so straightforward. It's so lovely. Come on, so lovely. Math can be so lovely. Okay, so now let's go to the next one. Let's go to 3. So for 3, it's saying a natural number. What does a natural number mean? From 1, 2, 3 to infinity, to come up with any number more than 1, it's natural number. A natural number is divisible by 3 if the sum of its digits is divisible by 3. Now look at a number like this. Ordinarily, if you were asked to solve, okay, now you will see that what works for 2 does not work for 3. Let's start from there. For example, let's find a number that ends with 3 that can be divided by 3, like 73. Let's talk about it. Let's see. 73. 73, the last digit of 73 is divisible by 3, right? But is 73 divisible by 3? Let's check. Divided by 3 equals to 73. Oh, it's taking my 7 to be 9. Sorry about that. Sorry. I need to correct that. It's not 93. 70, and I'm almost repeating that again. 73 divided by 3 equals to, you can see it's in decimal, which means it has a remainder. So what works for 2 does not work for 3. But if it is, for example, let's check 72 now. If it is 72 divided by 2, you can see it's ended with 2, right? Or if it's ended with 4 or 6, or let's see if it should be divisible by 2. Oh, sorry, I wanted to put equals to. Yeah, boy, it's taking it as equals to, so it's 36. No remainder. That's what we are talking about. So for 3, we are saying that if the sum of its digits is divisible by 3, take for instance 60. Let's take 12. So 12 is a digit. So let's add the digit of 12. 1. You see the way I write self. Don't mind my writing. 1 plus 2 equals 3. Now, is 3 divisible by 3? 3 divided by 3. Of course. Is what? 3 divided by 3. What's going on here? Don't mind my device, sorry. 3 divided by 3 equals 1. You can see that. So is 12. So we are now saying that because the sum of the digits, like of 12, 1 plus 2, that is equals to 3, because the sum of the digits of 12 is divisible by 3, then it means that 12 itself can be divided by 3, and we have 4. No remainder. That is it. So interesting and so straightforward. So this is the rule for 2 and 3. Let's try a bigger number. Let's say, okay, let's check the examples here. We have 4, 3, 5, 3, 3. Now, ordinarily, if we were told to solve, to check if 4, 3, 5, 3, 3 is divisible by 3, which will look too cumbersome. 4, 3, 5, 3, 3. 4, 3, 5, 3, 3. It will look too cumbersome. Like, you'll be like, how do I know if this can be solved by 3 merely looking at it? Because we already established that the fact that the last digit is divisible by 3 does not mean the number itself will be divisible by 3. So we are now saying, by the rule of divisibility now, that check if the addition of all the numbers, the digits, is divisible by 3. That is 4 plus 3 plus 5 plus 3 plus 3. What is the answer? 18. So because the addition of everything is 18 now, and we know already that 18 is divisible by 3. This still means that we still need to know some little things. We need to know our multiplication table, 2, 3, 4, 5, 6. You understand? So merely knowing that 18, because 3 times 6 is 18. So merely knowing that this is 18, we know that 18 is divisible by 3. So because 18 is divisible by 3, then we can easily conclude that this 4533 is divisible by 3. What will be the answer? Let's check. 14,511. Yes, and let's also check again. Let's check 14,511. So let's use purple to check for our answer. 14,511 times 3 equals, you see, 43533. That is it. So this is what we have now for today. We have checked the divisibility rule for 2 and for 3. We shall continue in our next video. I hope you enjoyed today's class. Don't forget, you can always reach out to us for your online math classes, music classes, music production, and birthday shout out. In case you would like to see samples, just DM and you see a sample of how we do all our services. You will love it. Thank you very much.